This lesson will be on solving work problems. Now, these are mathematical problems that involve the completion of work. The essential question for this lesson is, how do you solve math word problems that involve the completion of work? So what exactly do we mean by work problems? These are problems where they will give you information that one person can do a certain job in a certain amount of time, working alone. A second person can do the same job in a different amount of time, working alone. If that's the case, how fast can the two complete the job working together? So again, let's look at an example. So here is our example. Jen can mow a lawn working alone in 3 hours. John can mow the same lawn working alone in 2 hours. How long would it take them if they worked together? Well, it turns out we can use the same table that we used before for the problems involving percent or amount mixtures. So we can use that same exact table with some slight variations for this type of problem. Now, before we fill in the table, we have to understand that there is a formula involved. Just like distance problems are calculated by the formula distance equals rate times time, work problems have a similar formula. That formula is that work is equal to the rate times the time. Okay? Okay, so let's start filling out our table here. The first row is going to be Jen, okay? And this is going to be for Jen working alone, all right? Now, the first box represents the time it takes her to complete the job, okay? The second box is going to be the rate at which she works. And we'll see what that comes out to be in a second. And then the third box is simply going to be 1, because that indicates that the job is complete, okay? So the job is complete based on the rate she works times the time she works, and that'll come out equaling 1. All right, the second column is going to be John. And then the third column is going to be together, when they work together. I think I said column, I meant row. All right, let's fill these in. The first row, Jen. Jen can mow a lawn working alone in 3 hours, so her time is 3 hours. Okay, so what's her rate? Her rate is she completes 1/3 of the mowing in per hour. So her rate is 1/3. That's the amount of completion per hour. And then, of course, when we multiply these two, we simply get 1, which means the job is complete. Now, John, on the other hand, his time is going to be 2 hours. His rate, therefore, the amount that he completes per hour is going to be 1/2. So he completes 1/2 of the job per hour. Okay? Now, his third column here is also equal to 1. Okay? Because if he works 2 hours and his rate is 1/2 completion per hour, he'll complete it. So 2 times 1/2 is equal to 1. Okay? Together, same thing. This third column is going to equal 1. All right. Now, what's the rate going to be? Well, they're working together. So it's going to be, Jen's going to be providing a rate of 1/3. John's going to be providing a rate of 1/2. So basically, the rate, we add the two rates. So it's 1/3 plus 1/2. And then the amount of time, that's what we're looking for, that's our x. Okay? So, again, this is set up exactly the same as the previous table was for mixture problems. We're going to multiply the first column times the second column, and it's going to equal the third column. So whatever the hours is, times the combined rate, we add the two rates, is going to equal 1. So let's see what that equals. So I've got x times 1/3 plus 1/2 equals 1. All right, now I have to take and add these two fractions, 1/3 plus 1/2. Well, as you probably all remember, when you're adding fractions, you need a common denominator. So I've got to make a common denominator here. The common denominator between 3 and 2 is going to be 6. That means the first fraction I have to multiply by 2. And the second fraction I have to multiply by 3. Okay, so now what does this look like? Now we've got x times 2/6 plus 3/6 is equal to 1. Or x times 5/6 is equal to 1. Or if I multiply both sides by 6 and divide both sides by 5, I'll get x comes out equaling 6/5, or 1 1/5 hours. Okay, so there's your final answer right there. Working together, Jen and John will complete the job in 1 1/5 hours. Hopefully this will help you to understand work problems. All work problems can be done the same way using a table, and you won't be given all the information to fill in the table. Something's going to be an unknown, and you have to take and calculate what that unknown might be.